Hello everyone, I'm back with an interesting video. After a long, so much time. Okay, and in this video, our topic is chemistry. And I'm back with a new interesting video on the topic chemistry. And in this video, we are going to discuss completely about hydrides, which is H plus or H. So in this video, we are going to discuss completely about hydrides in detailed manner. Okay. So basically and mainly, what are hydrides? Dihydrogen. What is dihydrogen? Dihydrogen is nothing but H2. In certain conditions, so this is the definition of hydrides. So what are hydrides? Basically, what are hydrides? Hydrides are those chemical compounds in which dihydrogen, which is H2, reacts with certain almost all elements only in certain reaction conditions. Only in certain reaction conditions, dihydrogen reacts with almost all elements to form hydrides. I said almost all means it has some exceptions. Yes, chemistry means exceptions are compulsory. So okay, so exceptions is noble gas. It doesn't form hydride with noble gases like helium, neon, oxygen, etc. So like this, noble gases, dihydrogen doesn't react with noble gases, and except noble gases, it reacts with every element. With what are noble gases? Noble gases are group 18 elements. Yes, group 18 elements are called noble gases. For example, helium, He, neon, Ne, oxygen, Og, etc. So, why? Because noble gases are perfectly stable. Like helium, it completes its duplet rule because it's having 2 electrons. And neon, it completes its octet rule. It is having 8 electrons in its outer valence shell. So, androgen too, it completes its octet rule and it becomes stable. So, noble gases doesn't form any compound, they remain stable. Only the purpose they have attached in periodic table is just they are present. That's it. So, noble gases doesn't form any compound with any element. So, hydrides is also saying dihydrogen doesn't form compound with noble gases, and except noble gases, it forms compounds with every element. For example, sodium hydride NaH, calcium hydride, and beryllium hydride, and magnesium hydride, etc. Lithium hydride, sodium hydride, calcium hydride, beryllium hydride, magnesium hydride, carbon hydride, water. So like this, it forms compounds with different elements except noble gases to form hydrides. And in hydrides, there are 3 types. What are they? So in hydrides, there are 3 types of hydrides. So what are those 3 types of hydrides? First one is ionic hydride, and second one is covalent hydride, and the last one and third one is metallic hydride. I forgot to tell you something. What are alpha particles? So many persons don't know what are alpha particles, and they will get confused and tensed and this concept alpha particles. So what are alpha particles? Alpha particles are nothing but He2 plus ions. Alpha particles are nothing but He2 plus ions. What is meant by that? He, which is helium 2 plus ions, means helium doesn't have any electrons. It doesn't have any electrons, no protons. It has two protons and no neutrons. Only two protons. That's it. No electrons. That is why this it has only two electrons because its atomic number is 2, and it loses all two electrons and forms He2 plus ion, which is also called as alpha particles. Okay. So firstly, what is an ionic hydride? What is ionic hydride? Ionic hydride are those hydrides when hydrogen combines with an element which is more electropositive than hydrogen. Yes, listen carefully. Hydrogen combines with an element which is more electropositive than hydrogen. For example, so what are elements which will be more electropositive than hydrogen? S block elements. S block elements will be more electropositive than hydrogen. For example, lithium hydride, sodium hydride, magnesium hydride, beryllium hydride, calcium hydride, etc. So when hydrogen combines with an element which is more electropositive than hydrogen, what is electropositive? Electronegative is the atom having an ability to pull the electrons towards itself. Electropositive is nothing but to give electrons to another ones. That is electropositive element. Okay. So when hydrogen combines with electropositive element more than hydrogen, it forms ionic hydride, and the bonds in these ionic hydrides are ionic bonds. By name we can see that ionic hydride, it contains ionic bonds. So the final conclusion is that when hydrogen combines with S block elements, it forms ionic hydrides. Yes, and second one is covalent hydrides. Covalent hydrides. Yeah, sorry for the disturbance. And second one is covalent hydrides. What are covalent hydrides? Covalent hydrides form when hydrogen combines with an element which is more electronegative than hydrogen. What is electronegative? Just I have said, electronegative element is that the element having an ability to pull the electrons towards itself is called electronegative element. When hydrogen combines with the element which is more electronegative than the hydrogen, then it forms covalent hydrides, and the bonds which are in covalent hydrides are all covalent bonds. Okay, so what are the elements which will be more electronegative than hydrogen? Are p block elements. We have 4 blocks of elements: S block, P block, D block, F block. S block is electropositive than hydrogen. P block is more electronegative than hydrogen. For example, CH4 methane, NH3 ammonia, water H2O, HCl hydrochloric acid, HBr hydrobromic acid, and methanoic acid, CH3COOH, etc. So what are P block elements? Group 13, 14, 15, 16 and 17 and 18. So group 13 to group 18 elements are called P block elements. P block elements. So when hydrogen combines with P block elements or the elements which are more electronegative than hydrogen, it forms covalent hydrides. For example, water, methane, ammonia, ammonium, etc. are called covalent hydrides. And in this covalent hydrides, there are again three types. There are again three types of covalent hydrides. What are those? The three types of covalent hydrides are electron deficient hydrides, electron precise hydrides, and electron rich hydrides. So there are three types of covalent hydrides, which are electron deficient hydrides, electron precise hydrides, and electron rich hydrides. So what are the differences of these hydrides? First one, electron deficient hydrides. When an atom combines with hydrogen, still too it has deficiency of electrons. For example, boron hydride BH3. It has a deficiency of 2 electrons because it needs 3 electrons, and 3 electrons are filled with hydrogens. So there are 6 electrons. It needs more 2 electrons to complete its octet rule. So boron hydride is an example of electron deficient hydrides. Example BH3. So it needs more 2 electrons for stability when in BH3 compound. So example for electron deficient hydrides. One of the example for electron deficient hydrides is BH3. Yes, when the central atom of any hydride is unstable due to the deficiency of electrons, then those hydrides are called electron deficient hydrides. And you can write notes as if you wish, if you understand. And electron precise hydrides. When central atom of any hydride is stable, it needs it has the electrons how much it needs. It has electrons how much it needs. It is stable. When the central atom of any hydride is stable, then it is electron precise hydrides. For example, CH4 methane. It has when it needs 4 electrons because the valency of carbon is 4. It has 4 electrons. It needs more 4 electrons for completion of octet rule and stability. So those deficiency of 4 electrons are filled with 4 carbons, CH4, then it gains stability. So methane is an example of electron precise hydrides. Methane. And electron rich hydrides. In the name you can see rich means it needs extra, it has extra electrons. It can give more electrons. For example, NH3, ammonia. It needs more 1 electron. It has 1 electron extra. Also combining with 3 hydrogens, it has more 1 electron extra. Means ammonium, NH4 is also stable. Example is NH4. This is also stable, so it completed its octet rule. So it comes under electron precise hydrides. Electron rich hydrides, by the name you can understand rich. It has extra. It has more. Rich means what? Which has more money. And electron rich, which has more electrons, extra electrons, and they can give. So those are electron precise hydrides. And the third one, metallic hydrides. Metallic hydrides. And these metallic hydrides are also called interstitial hydrides. Interstitial hydrides. Because in every metallic hydride, hydrogen was thought to be in the interstitial position. What is interstitial position? See, when a compound has See, this is one chair. This is one chair. This is one chair again. Again, this is one chair. So here one person is sitting. Here one person is sitting. Here one person is sitting. Okay. See, there's a gap here between chairs, and here if a person is standing, then it is said that these persons are in interstitial positions. So same, there will be some gap between atoms, and in this gap hydrogen is filled. Hydrogen is occupied. So hydrogen was mostly in metallic hydrides, was in interstitial positions in metallic hydrides. So they gave the name interstitial hydrides for metallic hydrides. So that is why metallic hydrides are also known as interstitial hydrides. So okay, what are metallic hydrides? By the name we can hear the metal. Yes. So when hydrogen combines with metals are metallic hydrides. See, already we have finished S block elements and ionic hydrides, P block elements and covalent hydrides. What are left over? D block and F block. So when hydrogen combines with D block elements and F block elements, it forms metallic hydrides. In other words, when hydrogen combines with transition metals, yes, transition metals, it forms metallic hydride. Example for this is titanium hydride, aluminium hydride, TiH, AlH3, etc. Yes. So this is all about today, guys. Thanks for watching and stay tuned for next chemistry video. In that video, we will be discussing about characteristics of ionic hydrides